I had problem number 1, which reads, find all 3-digit positive integers such that if the integer is divided by the sum of its digits, the result is 28. So if we have a 3-digit integer, we'll call it ABC, and that's divided by the sum of its integers, a plus b plus c. We want this to equal 28. So another way to write this integer would be 100 times a, because a is in the 100s place, plus 10 times b plus c. And then again, that's divided by a plus b plus c, which equals 28. So we want to solve this equation. So if we multiply this over, we get 100a plus 10b plus c equals 28a plus 28b plus 28c. And we want to subtract these values over, and when we do that, we're going to get 72a minus 18b minus 27c, and that equals 0. And then we can recognize that all these numbers are divisible by 9, so we want to divide the whole equation by 9, and then you would get 8a minus 2b minus 3c equals 0. And this is the equation we're going to be working with. And our question's asking us to find all possible values for a, b, and c. So we're going to start off when a equals 1, and that would make this equation 8 equals 2b plus 3c. So when a equals 1, then we're just going to go through the values of b. So if we plug in a b equals 0, then that means 3c would have to equal 8, which does not work because 8 is not divisible by 3. If b equals 1, we find that when you subtract 2 from 8, 3c would have to equal 6, so that means c equals 2. When b equals 2, 3c would have to equal 4, which does not work. When b equals 3, 3c would have to equal 2, which does not work. And if b equals 4, then you would get 8 minus 8, so c would equal 0. And because c equals 0 when b equals 4, we know we don't have to test any higher values of b for when a equals 1. And then we go on to a equals 2. So this time our equation would be 16 equals 2b plus 3c. And again, we start with b equals 0, which means 3c would have to equal 16, which does not work. If b equals 1, 3c would have to equal 14, which does not work. When b equals 2, then c would equal 3. When we plug in b equals 3, 3c would have to equal 10, which does not work. B equals 4, 3c would have to equal 8, which does not work. If we plug in b equals 5 and subtract over 10, you would get 3c equals 6, which means c equals 2. Then b equals 6, 3c would have to equal 4, which does not work. B equals 7, 3c would have to equal 1, which does not work. And if b equals 8, we find that 2 times 8 is 16, so again, c would equal 0. And again, because c equals 0 when b equals 8, we know we don't have to test b equals 9. Then we go on to when a equals 3. And when a equals 3, the equation we would be working with would be 24 equals 2b plus 3c. And again, b equals 0, c would equal 8. When b equals 1, c would have to equal 22, which doesn't work. B equals 2, then we get c equals 4. When b equals 3, we would get c equals 6. When b equals 4, we find that 3c would have to equal 16, which does not work. When b equals 5, we get c equals 2. When b equals 6, we would get c equals 4. When b equals 7, 3c would have to equal 10, which does not work. When b equals 8, 3c would have to equal 8, which does not work. And when b equals 9, c would equal 2. And 9 is as high as we can go since we know b is a one-digit number. So then we move on to a equals 4. And this would give us 32 equals 2b plus 3c. When b equals 0, 3c would have to equal 32, which does not work. When b equals 1, 3c would have to equal 30, which does not work. When b equals 2, 3c would have to equal 28, which does not work. When b equals 3, then 3c would have to equal 26, which does not work. When b equals 4, c would equal 8. When b is 5, 3c would be 20, which does not work. When b equals 6, this would be 22. And when b equals 6, 3c would equal 20, which does not work. b equals 7, then we get c equals 6. When b equals 8, we get c equals 8. And when b equals 9, 3c would have to equal 14, which does not work. Then we're going to move on to a equals 5. And this time our equation would be 40 equals 2b plus 3c. And when you go through the whole process again, you find that our only solution is b equals 8 and c equals 8. And then we don't have to test a equals 6, because if you plug in a equals 6 to the equation, you're going to get, when a equals 6, you're going to get 48 equals 2b plus 3c. And when the highest values that both b and c can have are 9, and when you plug in for 9 for both of these, you only get 45. So we know we don't have to test any values of a are higher than 5. So then our answers are just the solutions that worked out. So when a equals 1, we would have the numbers, our final solutions would be 112, 140. When a equals 2, so we'd have 223, 252, 280. A equals 3, we have 308, 324, 336, 352, 364, and 392. When a equals 4, we found 448 works. So does 476 and 488. And our only solution for a equals 5 is 588. So these would be all our solutions that work in this formula.